So this is another differentiation rule. It's called the chain rule. So we can get the derivative of y with respect to x by multiplying the derivative of y with respect to a new variable u. So we'll introduce a new variable here and then multiply it with the derivative of the new variable u with respect to x. So if we have this given function, we can replace 7x plus 9 with the new variable. So let u be equal to 7x plus 9. Let u be equal to 7x plus 9. So we can solve for the derivative of u with respect to x. So using the different differentiation rules, no? So derivative of 7x is 7 and derivative of 9 is 0. And then since we replace 7x plus 9 with u, so we can write the original function as u raised to the power of 5. Then we can get its derivative with respect to the new variable u using the power rule. Now it's 5u raised to the power of 4, right? So using the chain rule, so we can solve for the derivative of y with respect to x by multiplying the derivative of y with respect to u and derivative of u with respect to x. So we have 5u raised to the power of 4 multiplied by 7. So we have 35u raised to the power of 4. And then you need to express the final answer in terms of the original variable x. So replace u with 7x plus 9. So it's going to be 35 times 7x plus 9 quantity raised to the power of 4. So this is now the final answer. So actually we can use the power rule, no, the general power rule here. Okay, so it's you're actually applying chain rule when you did the power rule because after reducing no, the power by 1, so you need to multiply it with the derivative of the base, no, derivative of 7x plus 9. So that's why it's called chain rule because sunod-sunod, no? So after reducing the power by 1, so sumpayanin mo siya with the derivative of whatever the base is. Okay, so it's actually chain rule, no, that was used in the previous examples. Okay, but it can be expressed as in any, no, the product of the two derivatives. Okay, so we have another example. Okay, what if the function is, so we have u to the power of n, but at the bottom, so meaning n is negative, no, 3. So same process. So we let this polynomial x cubed minus 5x squared plus 2x minus 2 be our u. So we can get its derivative with respect to x. So we have 3x squared, no, minus 10x plus 2. And then y will now be equal to 10 over u cubed. Okay, or you can write that as 10 times u raised to the power of negative 3. Okay, so we can get its derivative using the power rule. So it's negative 3, no, times 10, or it's negative 30, then u raised to the power of negative 3 minus 1, or it's negative 4. Or if you want to use the, set D8, okay, where the n is located, no, in the denominator, or the general power rule, no, just apply the one of the laws of exponents. So we can now solve for dy over dx by multiplying these two. So again, derivative of y with respect to u multiplied by the derivative of u with respect to x. So it's negative 30 u raised to negative 4 times 3x squared minus 10x plus 2. Okay, or you can plug in the u. So u is x cubed minus 5x squared plus 2x minus 2 quantity raised to negative 4 and then multiplied by 3x squared minus 10x plus 2. Okay, so you can have this as your final answer. You don't need to distribute this to each of the terms in this trinomial. Okay, and of course, you cannot distribute the negative 30 to each of the terms here. Okay, careful. No, there's an exponent, so you cannot just multiply directly, the whatever factor you have to each of the terms here because you still have an exponent. So this can be the final answer. Or if you want, you can transfer this trinomial, okay, after negative 30. Okay. And the last example for chain rule, you have, so before the next example, so let me just write that. When you transfer, the 3x squared minus 10x plus 2 times this. Okay, or since the given function is expressed with a positive no exponent, okay, so you can also have an answer negative 30 over this and then raise this to a power of positive 4. Now using the laws of exponents, you can transfer this expression in the denominator and then replace no negative 4 with positive 4. Okay. So all three are correct though. Okay. But if possible, no, whatever the format of the given function is, so you have enough time to express it using the format of, so the final answer no should be of the same format with the given function. So let u be equal to 4x minus 81. So let u be equal to 4x minus 81. So du with respect to x, or derivative of u with respect to x is 4, right? So the y here becomes square root of u. So for dy, du, we have using a special case for the power rule, no, where the exponent is 1/2. So it's going to be the derivative of u, okay? So meaning 1 and then 2, no, times the square root of u. So dy dx, so dy dx or derivative of y with respect to x would be 1 over 2 square root of u times 4, or that's 4 divided by 2 is 2. Okay, so that's 2 over square root of u, and then you plug in back the 4x minus 81. So square root of 4x minus 81. All right. So if using one of the differentiation rules mentioned no last time, so you can directly get no the derivative. So derivative of 4x minus 81 is 4, and then over 2 square root of u. So basically, we were doing chain rule, okay, in the previous formulas. So we are lang, no, explaining the concept behind those differentiation formulas. Okay, and using a new variable, introducing no, a new variable. Okay, so Next video would be about method no, of differentiation called implicit differentiation.